Can new scientific ideas shape the future of humanity? Did you know that the robot, which now works in factories, hospitals, and space missions, was once merely a product of science fiction? In 1920, Czechoslovak writer Karel Čapek popularized the word robot through his play RUR, or Rossum's Universal Robots. The word itself was suggested by his brother, Josef Čapek. At that time, robots existed only in literature. Today, they manufacture products, assist doctors during complex surgical procedures, enter environments too dangerous for humans, and participate in scientific exploration in space. In other words, today's imagination can become tomorrow's technology. History offers many such examples. Around the world, countries have learned from one another, created national research programs, developed advanced laboratories, encouraged the movement and exchange of scientific talent, and steadily increased investment in science and technology. China's scientific transformation after 1978 provides one notable example. Its strategy was clear. First learn, then adopt, improve, and ultimately compete with the world through its own technological capabilities. But humanity now faces a much larger question. Will countries merely compete to adopt technologies developed elsewhere? Or will they cooperate to imagine and create entirely new technologies for the future? Across the world, countless students, scientists, engineers, and independent thinkers may have revolutionary ideas capable of transforming human civilization. But do they receive sufficient funding, access to modern laboratories, expert guidance, and the freedom to experiment? Governments, universities, research institutions, and international scientific organizations should work together to develop clear and ambitious scientific roadmaps. These should define long-term research priorities, funding requirements, timelines, and measurable objectives. Our collective goal should not be limited to technological competition among nations. It should also include the creation of new scientific fields capable of addressing humanity's common challenges, from climate change and resource scarcity to interplanetary travel and the long-term survival of our species. A new science fiction novel, Race for a New World, also envisions several speculative branches of futuristic engineering. The novel is available on Amazon.com. One such fictional concept is receptive rays engineering and technology. The search for distant planets faces numerous obstacles, including extremely weak signals, the overwhelming brightness of host stars, limited angular resolution, and interstellar dust. Planets have been discovered within the Alpha Centauri star system, but no Earth-like planet conclusively suitable for human life has yet been confirmed there. Modern observatories such as the James Webb Space Telescope study light, arriving from the universe with extraordinary sensitivity. However, we see a distant planet as it existed when that light began its journey towards us. If a planet is 10 light-years away, for example, we observe it as it was 10 years ago. Could a future technology detect extremely weak signals more efficiently and enable a more precise analysis of a planet's atmosphere, surface, environment, and potential for life? Imagine standing in a noisy marketplace while someone calls your name from far away. This speculative technology would attempt to filter out all the surrounding noise and isolate that single voice. In the novel's fictional vision, billions of receptive rays scan the space-time environment ahead of a spacecraft, assess gravitational variations and potential hazards, and help identify safer routes through space. The novel also explores the highly speculative possibility of faster-than-light travel. This is not an established technology. It is a science fiction concept intended to inspire scientific curiosity, discussion, and future research. After all, every invention begins with an idea, a question, and a spark of curiosity. The question now is, will humanity have the courage to transform bold scientific ideas into shared global research objectives? Will nations use science merely to compete with one another? Or will they also cooperate to imagine and create the technologies of tomorrow? Can the world's governments, universities, scientists, engineers, and citizens unite behind new scientific objectives that could improve life on Earth and eventually carry humanity towards distant worlds? The future belongs not merely to those who use technology, but to those who have the courage to imagine it.